talking about problem solving as well as in our poems that we're going to be doing today. So right now we're going to be talking about multiplication. Multiplication takes some dedication. Multiply everything together, then you can have your answer forever. So multiplication right now, we're going to be using the equations f of x is equal to x to the sixth and g of x is equal to 4x. The equation we're going to be using to plug these two equations into to find h of x is h of x is equal to f of x multiplied by g of x. So step one is we're going to plug in what's given for f of x and what's given for g of x. Like so, h of x is equal to x to the sixth multiplied by 4x. All we did was plug in what was given for f of x and what was given for g of x. Step two is we're going to multiply everything together, such that as h of x is equal to 4x to the seventh. Now how we got this was the 4x comes from g of x, and the seventh comes from, you have x to the sixth and you're multiplying. When you multiply, you associate that with addition. So on the 4x, there's an implied 1 to the exponential power. That's what we have. So 6 plus 1 is going to give us 7, and that's how we get 4x to the seventh. On our last step we're going to be doing for multiplication, we're going to simplify. We're going to simplify as much as possible. And our simplified answer is h of x is equal to 4x to the seventh. Now, we're going to be talking about division. Division takes precision, simplified to the max. Then you can just relax. So we're going to be doing the same equations that we did for multiplication for division. F of x is equal to x to the sixth and g of x is equal to 4x. Now the equation's different, but we're still using the same number. So the equation to find h of x is now h of x is equal to f of x divided by g of x. So step one we're going to be using is to plug in what's given for f of x and what's given for g of x. Like so, h of x is equal to x to the sixth divided by 4x. All we did was plug in what was given previously. Our second step is we're going to set f of x over g of x, like so. So now when we do this, it's going to be easier for us to do the actual division part. So now we have h of x is equal to x to the sixth over 4x. And our last step is to simplify and to divide. So when we simplify and divide this, our answer is going to be h of x over x to the fifth divided by 4. Now how we did this is, when you think about division, you usually think of subtraction. So division and subtraction are what go together. So we can essentially move this x to the top and subtract it because it's not bounded by addition or subtraction. It's bounded by multiplication and division, and we're allowed to take those away. We're allowed to separate those. So what we did is we subtracted an x on this side, and we could subtract it on top as well. So 6 minus 1 is equal to 5, and that's where we got x to the fifth divided by 4. And that's as simplified as it can go. The last thing we're going to be talking about is addition and subtraction. Addition and subtraction are very similar. You can only add or subtract terms that are alike. So for this one, we're going to be using two different equations for f of x and g of x. F of x is equal to 2x to the fourth plus 3, and g of x is equal to x minus 12. Now the equations for these are different from the multiplication and division. H of x is equal to f of x plus g of x. So that's going to be our addition equation. And h of x is equal to f of x minus g of x is going to be for our subtraction. They're very similar, as you can see. Step one is we're going to plug in what's given for f of x and what's given for g of x. Blah, blah, blah. So h of x is going to be equal to 2x to the fourth plus 3 plus x minus 12. And for our subtraction problem, we're going to be doing h of x is equal to 2x to the fourth minus x minus 12. Our second term is we're going to add and subtract like terms, such that of this. So when you're adding and subtract like terms for addition, it's usually easy. You can fly by them, you can tell what they're like. Now what you can get mixed up a little bit is when you see 2x to the fourth and x. You automatically say, oh, x. They have a common factor. Wrong. 2x to the fourth is an x to the fourth power. What we have on the other one is just x to the first power. Now, x to the fourth power and x to the first power are totally different things. Therefore, you cannot add those together. But what you can add together is the 3 and the negative 12. Although they are one's from a negative and one's for a positive, they are both the same. They're both integers. Therefore, you can add this together. Now for subtraction, you have 2x to the fourth plus 3 minus x plus 12. So, like I said earlier, you cannot add or subtract the 2x to the fourth and the negative x because they are not the same. But what you can do is the positive 3 and positive 12. So our last step is to simplify these equations. And the simplified versions of these equations are h of x is equal to 2x to the fourth plus x minus 9. Now what we did to get the minus sign is we minus 12 and we added that to 3, and that'll give us our negative 9. And then our subtraction equation is h of x is equal to 2x to the fourth minus x plus 15. You cannot forget to distribute that negative to both sides, because if we distribute the negative, it'll give you negative x, so it'll give you a positive 12, which will then, if you add 12 to 3, it'll give you 15. Lastly, operations on functions are very easy. No need to get a little queasy.